So in this quick short video, I will be discussing advanced APIs of TypeScript, which are very basic and very commonly used. The first API is the pick API. Now imagine you have a interface known as user already. An interface do not uses the equal to sign of an interface in which it has ID, which is number. uh, you have name, which is a string, and you have email, which is another string. Now you want to create another type. Basically interface acts as a type only in JavaScript, in TypeScript, my bad. It acts as a custom data type for you as a programmer to keep the types of imply to imply the type checks. So if you want to create a custom another type based upon this interface type, you go like this. You create a custom user type. You have two ways to do this. Like let's say you only want the name and the email of the user in this type. So you can just define it like this. Email, and that would be fine. But the problem here is, let's say I change the email from in the future I change the email from string to number, so I need to change it here as well. You need to do things twice, and as you know, programmers are lazy, so we don't do that. Instead of that, let's revert this back to string, and instead of that, you use the pick API, which the TypeScript provides. It is not present in JavaScript. In the pick API, you first of all, instead of using normal braces, rounded braces, you use this angular braces. And the first parameter is the interface of the type you want to pick from, which is user in our case. And after that, the parameters of the attributes that you want to pick from in, and they should be separated by this pipe symbol. As you can see, this pipe symbol. Let me write it completely, then I will show. This is the pipe symbol. These are the attributes of this type. Name and email are the attributes of interface or type user. So these are in quotes and separated by pipe. Now if I make a user of type custom user type, and let's say I give it name, home, and email at the rate gmail.com, it will be fine. But let's say I define ID for it as well. It will complain the ID does not exist. You can see ID does not exist. But like I want to keep the ID, so I can, if I want to keep the ID, I can just use user as the type of this user, and that will be fine. So that was big API. After that, we're going to study the partial API. Imagine that uh, you want to create a type. Let's say that's a custom user type, and in this it has two attributes, name and email. But you only want to take email and you don't want to take name, for example. So normally what you would do is, you have a, let's say I will show you in user only. If you have a type for interface, you just add a question mark here, indicating that this attribute is optional. But you can do this in the original interface. But what about this interface that you created using pick? That is a derived interface or type. How would you apply that optional thing to the attributes of this derived interface? What you do is, you use the partial API, system user type, name it whatever you want, just use this partial thing and pass the uh, custom user type to it. And after that, let's say you create a user one, and the type of the user is partial custom user type. And let's say I'm only willing to give the email, my email, home@gmail.com. It's fine, no problem. But if I remove it and use this custom user type, it will give me problem because name is missing. So if I want to make it optional, the attributes optional, then I use this. Hover over it. I can't hover over it currently. Let me check it. Currently, I can't hover over it, but the partial customer data type, it looks something like this. Partial customer data type, it looks like this. Email, which is optional attribute, is a string, and name, which is an optional attribute, is also a string. It looks currently something like this. If I comment this out, it will still give me no error. But the difference between this approach and the partial API approach is that partial API helps you define the optional things in derived types. This type is derived from the first interface, that is user. So this was about the partial API. After that comes the, wait a minute, let me remember. After that comes the read-only API of TypeScript. Uh, I will remove this. Let's say you have an const array which is of type like this: name, home Satpathy, home, let's say, and ID, which is 12, and you have the repetition of this. You are basically repeating this. You have uh, multiple elements like this. One, Lakshay, 14, 15, something like that. Okay, you have you have an array which is an array of objects, and each object contains a name and an age. Now, let's say in future I assign the first element of array, and then first element of array I change the ID of that to let's say 15. From 12 I change it to 15. TypeScript allows me to do that, but I have defined the array as constant, so it shouldn't be. So in order to enforce that I cannot change the program cannot change the contents of an array or an object, we use read only API. Let's say I define an interface. Let me go back. Now there's an interface. We have an interface named user, and if I create a object using this interface, let's say ID would be 12, name would be home, and email would be home satpathy05. That's my actual email. Anyways, so if I have this user and I do user.id 15, it doesn't complain. But if I make this ID read only, then it will complain. Cannot assign ID because it's a read only property. So in order to prevent the program in future from modifying this ID for this particular user or object, user's object, I can apply the read only property to this particular attribute. Let's say I want to apply the read only property to all the attributes. I can first of all do this, but there is an easy way for this as well. Let me quickly remove that. There's an easy way for this. It is using this read only. It will make sure that none of the attributes of this user is modifiable after it has been assigned. Now the difference between this is the capital R. Here you are using the capital R, while in the earlier example you were using small r. That is the difference that you need to keep in mind. After that comes the what? Let me quickly check it out. After that comes the record and the map. Now record and the map, record is basically a way for you to define nested objects type. I will show you what I mean. Let's say I have an interface named user, which is just name, which is a string, and an age, which is number. Now I want to create another interface which is users, which is first of all the key should be a number, which should be an ID, and the value should be a user. You're basically creating an object which is a key value pair, and the key should be a number and the value should be an user, which is another interface that we have defined. Now if I make a users whose type is users and make it so that the first user is one and his name is, let's say, Om, and age is 19, and then the second user can come having the same thing, and it will go like this. That is a way to deal with this problem. Basically you have a users which is which has a nested let's I will explain this to you using this users object. It itself is an object which contains values which are themselves objects. It's a nesting situation. I will turn that off. So it is a nesting situation. So in order to avoid that, in order to write cleaner syntax, you usually do this. This would remain same. You will just replace this with this. You will use records. You will create a type users, and you will use record, and the first value of the record should be a string and the second value should be a user type. And if you use this type of user, it will not get error. That was the that was the record API for you. Then comes maps. Maps are basically another way to store the key value pair data. It is a data structure. It comes from C++. So many people find it easier, who are switching from C++ to JavaScript or TypeScript, to use maps instead of JSON to store the key value pair. They find it easier. I'll show you how to declare a map. User map, and it will be map. You can define the key value pair. That is not how you define a map, apparently. New map. You use this new keyword. You use this to define a key value pair. Basically, what this user map contains. User map contains this user map is destined to have string as a key and number as a value. This kind of pair, key value pair. So how do you put elements in a map? You use this set. Let's say I want to set home as I want to set home as 12. You will use this syntax to add values to the user map, and if you want to read values, you use this. I do console.log user map dot get home. So it will return me 12. That is, it is returning me the value corresponding to this key. That is map. That is just another way to store the key value pair that are apart from JSON. You can use anything you want, but many people find this dot get and dot set syntax friendly, and these are the people who are usually coming from C++ background. So that's that. Apart from that, we have exclude. Exclude is similar to pick, but it only works on type, and the type should be a group of literals. I'll show you. Event type, and it can be, let's say, click or scroll or page resizing. We have three events, and event type can be either three of these. But you want to create a stricter event type. Event type. So you can use the exclude API. It gives the first would be the type that you want to exclude from. The second should be the attributes that you want to exclude from this type. So if I, let's say, make a const event which is of strict event type and give it a value of click, it will give me an error. Not redeclare block scope variable event. Have I used event somewhere else? Oh no, let's say I give it my event. Now, click is not assignable to strict event type, but if I do this, I use crawl, it won't give me any problem. If I do click, it will give a problem because I have excluded click from this strict event type. If I change this to event type, it will not give me error. That is the use of exclude API, but it is quite different from pick API. It is similar in that sense. It is doing this opposite thing as what pick is doing, but the difference comes on which things it can be applied. Exclude can be exclusively applied only on types, and the type should be a set of literals. These are literals, these are strings, these are set of strings. Event type can either be click, scroll, or page resizing strings. So these are literals. And after that comes the Zord inference. Zord inference in TypeScript. Let's say I have imported Z from Zord. Okay, and then I have created a user schema. Let's say user schema as Z dot object, and it should contain a name which would be Z dot string, and it would be minimum, let's say, 2 characters, and I have an email of Z dot email, and let's say it's optional. Let me quickly check the syntax. Sorry for that. I am missing the parenthesis here, and the parenthesis here as well. Email, it should be okay. It is string dot email. Email. Now that's fine. Now if you want to create a type of this user schema, you can use this thing, type of user schema equal to z dot infer, and we give type of user schema. It is infer only, no? It should be infer. Infer does not exist on type of. What is the problem here? This is a piece of code that you're gonna need. It is not const, it should be type. That should solve the problem. So that was the few advanced APIs for TypeScript. And I forgot to mention that this map thing is not specifically for TypeScript, but it can be applied in JavaScript as well. But apart from it, everything else is specifically for TypeScript only. So thanks. Let me quickly stop this recording.